Next, let us take a look at an application of logarithms, mainly half-life calculations. In our example number 1, the question is asking us to figure out how long it will take for a 40-gram sample of I-131, which has a known half-life of 8.040 days, to decay to 1/100th of its original mass. So how long will it take for 40 grams to go down to 1/100, or 1/100th of its original mass? Now, to be able to do this question, there are a few things we need to know, and we're going to solve the problem the way you might see typically in your chemistry textbooks, because there is a slightly different way to do it using in your math textbooks. You might do them solving the formula A equals PERT, P times e to the RT. But for the purpose of this presentation, we're going to use the chemistry approach, which we can assume it's a given that 1/2 to the x equals fraction of a substance remaining after x half-lives. So here x represents number of half-lives, and 1/2 to the x represents fraction of a substance remaining. And if you think about that, let's say that if x equals 1, you get 1/2 to the 1 power. That would be 1/2 or 0.5. And again, by definition, half-life is the time it takes for a substance to go to half of its original amount. So if there's exactly 1 half-life, you end up with 50% of the original amount. If number of half-lives is 2, that means it goes to half of its amount after 1 half-life, and then half of a half, that will be really 1/2 to the 2nd power based on the formula, which is 1/4, or it'll be 25% of the original amount. So as you can see, if you plug in number of half-lives into this formula, it's going to give you the fraction of that quantity remaining after the given number of half-lives. So with that formula and with that understanding, let's try to solve the problem. So we want to end up with 1/100 of the original mass. So we're going to set 1/2 to the x equal to 1/100. And notice what happened here. 1/2 to the x equals 1/100. The unknown x appears in the exponent. So that is the perfect situation to apply the natural log function. Because think about it, how else would you solve an equation? You could not take the x root of both sides. You could not take the square root of both sides. That's not going to do the job, right? So what we need to do is anytime the unknown appears in the exponent, we need to apply natural log to both sides. And that's exactly what I did in the next step, apply natural log. Now you can see those properties we learned previously will be very handy. The x can be brought to the front as a coefficient, and that will bring us to this. And finally, to solve for x, what would you do? You would need to divide both sides by ln of 1/2. So that's what I did in the last step, divide both sides by ln of 1/2. Both the numerator and the denominator can be evaluated using the ln key of the calculator. And when you take the ratio, you will find approximately 6.644 half-lives. Because remember, x gives you number of half-lives by definition. Now that is not the answer though, because they didn't ask for that. They want to know how long will it take in days, not in number of half-lives. So there we can do a quick little conversion. So if 1 half-life equals 8.040 days, and we want 6.6 half-lives, so you can simply multiply or use a conversion factor to see it even easier. So 6.644 half-lives, and the conversion factor is 1 half-life equals 8.040 days. So here the half-lives cancel. Again, you didn't have to do it this way, but you can also do it using a conversion factor. And the answer is 53.42 days. So that answers the question. How long will it take for 40 grams to go to 1/100th of its original mass? And the answer is 53.42 days. Okay, another example using half-life is as follows. Suppose that 100 grams of an isotope with a half-life of 36 hours is present at time 0 or initially. How much time will have elapsed when 5 grams of that substance remains. So to go from 100 grams to 5 grams, how much time will have elapsed? Now to solve this question, first let's take a look at the intuitive approach. The intuitive approach doesn't use any formulas. So starting with 100 grams, after one half-life, you get half of the initial amount, which is 50 grams. After another half-life or two half-lives, you get half of 50, which is 25 grams. After another half-life or three half-lives, you end up with half of 25, which is 12 and a half. Now we're supposed to end up with 5, so I'm going to keep going. So after taking another half or four half-lives, you get 6.25. And notice to get to 5, you need to go one more half-life. So a full half-life would give you 3.125. So we're not really going full because we want to end up with 5 grams. So somewhere between 4 half-lives and 5 half-lives. So I'm just going to estimate very, very roughly 4.3. You could try 4.4. Again, remember, this is a very rough estimate, but all we're saying is about 4 point something. And each half-life is 36 hours. So 4.3 half-lives, multiply that by 36, and you will get roughly 154.8 hours. So that's our rough estimate, about 154 something, 150 something. Now let's do it using the actual formula approach. So remembering the formula from the last problem, 1/2 to the x, where x is the number of half-lives, gives you the fraction of a substance remaining after x half-lives. And there's one more formula which is pretty intuitive. So if you take the original amount of a substance and if you multiply that by 1/2 to the x, that should give you the final amount of that substance remaining after x half-lives. That should make sense because 1/2 to the x will give you the fraction that is remaining. So if you multiply the original amount by the fraction, you will get the final amount. So for example, if the fraction remaining was 50%, you would take the original amount and multiply it by 0.5, and you would get half of the original amount remaining. So for this question, let's see what we were given. We have 100 grams of the initially, so this is going to be replaced by 100 times 1/2 to the x, and we also know the final amount. The final amount is 5 grams, so we're going to put 5 on the right hand side. So let's do that. So 100.0 with the given significant figures times 1/2 to the x equals to 5.00. Now to solve for x, yes, the x is indeed appearing in the exponent, but remember, we cannot apply the natural log until we have isolated our exponential term. In other words, we must get rid of this 100 first by dividing both sides by 100. So that's what I did. First of all, divide both sides by 100, 5 over 100 with significant figures, and all gives me 0.0500. And do you see the next step? The unknown is in the exponent and nothing else is in front of your exponential expression. So perfect situation to apply logarithm to both sides. Of course, you could have applied log base 10. In this situation, I'm going to apply natural log. So apply natural log to both sides. And we get this. Remember that you can bring the x down after you apply natural log. That's what you see in the next step. X times ln 1/2 equals ln of the right hand side. And finally, to solve for x, all we have to do is a simple division. Divide both sides by ln of 1/2, and voila, we have the answer. Again, you're going to need to use a calculator, of course. Simplify your answers and you're going to get 4.32. But remember what 4.32 is. It's not number of days or years, it's number of half-lives. So we're saying it's going to be 4.32 half-lives. Now previously we had estimated this 4 point something, right? Here we're getting more accurate answer as 4.32. And since one half-life equals 36 hours, all you have to do is multiply this by 36 to get the answer, or using your conversion factor method, 4.32 half-lives multiplied by 36 hours divided by 1 half-life. Since 1 half-life was given to be 36 hours, we can write that factor here and cancel the HL or half-life um, units, and you will be left with the hours, or 156 hours. And the nice thing is to notice how close this was to the answer we got earlier without using any natural logs, by just using our intuition. And I would highly recommend anytime you can do that and you can check your answers using just intuition, definitely something good to do. You will have a way to check the final answers, even though very roughly. So I hope that these 3 presentations on logarithms with different bases, such as base E or other bases, help to form a solid foundation on natural logs and their applications.